Hey everyone, thank you so much for coming. Absolute delight to have you all here. And thanks to the people who traveled and even the people who didn't have to travel that far. Delight to have you here. Alex and I are going to give you what we think is kind of a kind of more fundamental view of what governance is, based on our own explorations of the field, where we've been trying to do some sense making and figure out how we wanted to, I guess, create some value, like really try and solve governance problems. Importantly, we're not here to talk to you about mechanisms. We brought some incredible people here today who have those mechanisms, and they're going to explain them, and just as Bo did, is going to, that's the thing that they're going to do. What we're going to try to do is provide kind of this middle path where we kind of look at, take things from our point of view and try to give everybody in the room a shared frame for thinking about governance, specifically protocol governance of blockchain protocols. So that's what this is an attempt to do. We call that framework alignment games. So, I don't know if anybody knows Venkatesh Rao. I'm sure some do. He's given lots of talks in the crypto ecosystem. He's currently running a program called Summer Protocols. He has this great quote, which he says, "As they evolve, good protocols tend to rise to the standard articulated by Milton Friedman. They make it profitable for the wrong people to do the right thing." And we love that because it has this nice basis in incentives and obviously the language of the field that we find ourselves in. Mechanism design, and so we just really like that as a description of protocols. So I'm just going to start with this question: what is protocol governance? There's actually so many ways of defining it that it becomes really hard to figure out how to make progress or to reason about it. So the first thing we tried to do was just remove things. Like, can we just say what it isn't? And we just pushed out tons of descriptions, tons of different disciplines, and it allowed us to kind of focus on one discipline and one model. So we're going to start off with this is going to be a bit rudimentary, but hopefully we can, just like Bo did, build up brick by brick, and everybody should have a shared understanding by the time we're done. A blockchain protocol, we're going to describe it as a set of rules that specify how entities in a network can interact. So that means that if I know that someone else interacting with the blockchain protocol can only take certain actions, then I can kind of predict the action space, the space of possible actions. And we like that because it means we can lower our transaction costs. Specifically on blockchains, you have these like three main components of transaction costs: one around triangulation, so finding people to actually interact with; another one around trusting people; and then transfer, as well, actually executing. I just wanted to show this diagram, which we often use, which just says, think about a protocol as just being these functions that you can call that sit on chain, and then this other function called like update those functions, and that's governance. It's like just doing this update job. It's also self-referential, so you can update itself. And specifically looking at, say, Uniswap as a protocol, these are a couple of functions. This is actually the add liquidity function from V2, and it just has, as you said, you call this function and you have token 0 amount, one token 1 amount, another token. You can't add liquidity in any other way. That's it. It's been defined, it's been deployed, that's it. So you can imagine everyone's going to add liquidity in the exact same way, so you have a predictable action space. This is swap in V3. And again, you call this function and you give it some arguments, the recipient, and some stuff I won't specify that's not that important, and some call data, and then and it returns like, you've done this one. So hopefully that gives you a really tangible example of what we mean by protocol. It's literally just these rules around how you can interact. Now what's protocol governance? And this is a set of rules that specify how to update that protocol. So we want to change that swap function. How do we do it? And it includes, we like to break this down into 4 real buckets of rules. The first one is protocol updates. Here's the code. We want to change the code. Deploy Uniswap v4 is an example of a protocol update. Protocol parameter updates. This is look at the protocol, change some parameter that we've defined is changeable by governance. So for example, set Uniswap protocol fee switch on the ETH USDC pool. Number 3, policy updates. Update Uni v3/v2 deployment process. This is like things that are, I guess, less tangible, process, policies, just rules of interactions. And 4, treasury allocation. So allocate 25,000 Uni to the accountability working group. So we're going to split these tokens, we're going to send them somewhere. Everything make sense? This is actually an example from the Governor Alpha contract, which is what Uniswap uses. And this is interesting only because this is talking about the state of a proposal. And one of these else if statements is this one. Else if the 4 votes are less than or equal to the proposal against votes, or the proposal 4 votes are less than the quorum, defeat the proposal. So return proposal defeated, update the state, and don't queue this. It can't be executed. And And that's pretty much it. Like, and on these rules, you can kind of run all of Uniswap governance. And obviously, you think about what Uniswap governance currently does. It kind of manages this treasury that's currently around like $4 billion. These are the rules. So why is governance important? Eric Alston, who's from Colorado as well, he's going to be giving a short talk tomorrow. He's going to dial in. Unfortunately, he's not going to be in here in person. He has this really nice statement. He says, the need to adapt a set of network protocols is emergent. And what he means is, I always think a nice model we used to have for smart contracts was the idea of a vending machine. Imagine I put things in, you can just come in, you can take out what you want. And this is a very old vending machine, and it has a whole bunch of drinks that nobody would want to drink anymore. So at some point in time, we might fix something, and then we learn more about the world, things change, competitors turn up, we get more information, or we realize the thing is broken and we need to change it. And so we have this emergent need to update. And the way I like to think about it is, we have this action space. People want to provide liquidity. And then we want to create a protocol that allows us to kind of only execute actions within the space. But that space might change. Maybe I want to execute transactions in things that we didn't originally think about, like real world assets, for example. Or I want to change the way that I swap a token, because that token is a stable coin and it's always going to trade one for one with another one. So I don't care about a whole other range of prices. And so we find these things over time and we need to change. If we actually don't do this, we don't adapt, then we end up with this kind of like ossification where things just decay. There's another example of a protocol that has decayed. This is Gopher. Obviously, you can see here a reference here to Gopher instead of HTTP or other document transfer protocols. And this was, it came from academia. It came from, I can't remember which university it came from. But this ended up failing. It was really succeeded by HTTP. And the reason is that HTTP was just more extendable. It had this like hyperlink model, which meant that people could use it to embed the things they wanted. If Gopher was able to adapt, it could have integrated that information and maybe provided something that was much more useful, and it wouldn't have decayed. So this is the idea of how protocols change over time. But we have this tension. So we know users value a predictable action space, right? This is useful. If I can lower the actual transaction value, it increases the space of transactions I can conduct. So ideally, this creates value. But also, they require that the action space adapts over time, because it might ossify and it might be something I don't want to use. So we have this kind of tension. And so we kind of come to a proposition that a protocol's value is a function of the predictability of its governance mechanism. So you want governance mechanisms that produce like predictable results. You don't want things that are scary, and that's why in crypto, because we have this very scary, unpredictable mechanism called token voting, people tend to not use it. They don't rely on it for things because it produces unpredictable results. And Olsen actually has a really nice paper which talks about constitutions and talks about how constitutions change over time in different nations, and how you can actually map the amount of changes in a constitution just in terms of language and the developmental success of an economy. So the more changes, the less predictability, the less developmental progress. So why is it important that we decentralize our protocol governance? So Nathan Snyder says, decentralized technology alone does not guarantee decentralized outcomes. We can still have decentralized tech, and we can still make very centralized decisions. And I think this leads to some funny setups. There's a really great video online of someone trading this very aptly titled Squid Game. As you can see, the number goes up, and then the number goes down as the developer's rug pull. So if you have unfettered ability to change a protocol at your whim, then obviously you can do whatever you want. And so there's this massive power imbalance between the people who actually run the protocol and can update it and the users. So centralized protocol governance equals strong incentives to change the rules arbitrarily, which we want to protect against. So we just wanted to give some examples, and I'm going to hand over to Alex soon, who will kind of walk through the examples that we're considering for our problem space. But the way that we like to think about governance mechanisms is kind of in relationship to consensus mechanisms. So we have a bunch of transactions that people are sending because they want to update the state. They're candidates when they're transactions. We have some kind of black box mechanism, and it produces state updates to the blockchain. We have proof of work. Obviously, we know the kind of trade-off space of proof of work, proof of stake, and delegated proof of stake, which is funny because proof of stake almost always collapses into delegated proof of stake as a mechanism. So they have some relationship. But in our world of governance, we have contributions. We have actions that people are going to take. And then we have some mechanisms here. and then we have protocol updates. And we said token voting, which is one that we all know very well. It's just voting weighted by tokens. We have Futaki, which Bo spoke about, and Robin can talk more about his talk. And then we have technocracy, which is basically just how we describe how Ethereum runs, for example. You just have some meritocracy in the middle that's based really on technical aptitude, and then the people who rise to the top of that get to decide. And it's uninterrogable, and we just say that's fine. And lots of people call democratic systems eventually have these kind of technocracies at some part of them. And so some of the problems that we see in protocol governance, we actually did, at Robin's suggestion, we actually did run a game yesterday, and the game was this very simple setup. A few people here played the game, and it was simple. We just said we will give everybody some cards. They have to draw something, given a prompt like a car, and then we will randomly distribute those drawings to people, and they have to rate the drawing. But we will randomly insert an attacker, and nobody will know who the attacker is, not us, nor the people in the group. And there's a probability there's no attacker. Anyway, we ran this game, and it became really difficult to understand whether an attack was happening, because everybody had different priors about what they were rating, what constituted the best rating you could give. Was it all the way at 5? Was 4 good? And so on. We saw people trying to figure out what these kind of set this like level playing field at the beginning until we kind of limited people from talking. So this is a great example. A team have gone to Arbitrum, and they've had, I think they passed this proposal with 75% of all token votes to give them about $250 million. And it's for a gaming ecosystem fund, and I think they are taking $25 million as the admin fee. And so many people in crypto are mad about this. They think this is terrible, but this seems to be happening with a lot of support inside this community. And it's very difficult to understand whether this is an attack or if this is totally fine and very good for Arbitrum. And this is one of the problems we have. It's like difficult to detect an attack. It's difficult to detect misalignment, and even just outright attacks. You know, and there's actually loads of examples of things that are where people can kind of ratchet up over time if it's worth their time to be nice up front and then actually just change to being malicious later on. And this is we put together this June dashboard when we were first starting to interact with Uniswap, and this just shows the participation per proposal in terms of the individual accounts. And obviously we know that accounts aren't, they're not Sybil resistant. We just have lots of different token holders, and we have this weird spike here. This is when I think it was Scroll Network were trying to get Uniswap to deploy to their network, and then other than that you just see this like the voters fall off over time. And this is one of the other problems of like free riding and apathy. If you are currently involved in governance, you're spending time doing governance, there's a cost to you, and if you don't do any of that work, you just sit there, you get the benefit. So eventually it's like kind of default strategy is you just might as well free ride on the work of someone else, and normally it's the larger holders because they have much more of an incentive to participate because they get more of the return, but not all of the return. So eventually they will free ride as well. So what we tried to pull together was a framework, and this is not like a theory, it's just supposed to be a framework to help us understand how to approach governance, and it should allow us to start bucketing and comparing different types of mechanisms for this exact problem. And it's simple, it's just given an objective, so we pick an objective, Bo mentioned objectives as well, and objective selection is itself a problem, but given an objective such as maximize total value locked, evaluate a contribution, so a proposal to set the protocol fee switch, and then determine its alignment. So -1 being an attack, 1 being something that's value positive for the protocol. And this is quite useful. It just gives us a way of navigating this conversation, speaking to people, actually just evaluating things that are happening and kind of designing our own mechanism. So question, and this is where we're kind of going to go for the rest of the talk, is can we use alignment games to produce a mechanism that reliably allocates resources for contributions that achieve an arbitrary objective? It's a hard question, but this is where we start. And I will now hand over to Alex.
Yeah. I remove this, if that's fine with you. Okay. Hey everyone, I'm Alex. Yeah, so I'll take this to be a bit more practical and look at a practical problem and reason using the alignment game framework and think about what kind of mechanisms we can use to further an objective within protocol governance. So yeah, we're looking into distributing rewards. So basically, to be very concrete, at Uniswap there is the delegation compensation question. Which is a form of reward distribution. And again, within alignment games, we think about participants as contributors. So in terms of a delegate, that's going to be producing proposals, of course, but also any form of work that is useful to help the protocol pick the best proposals, obviously. And again, as Vaughn has mentioned, there's always going to be a latent objective that needs to be defined in some way. So we'll explore a bit as well the challenges around that. So an objective can be obviously token price, most obvious one. It can be also TVL or order flow when token price is maybe not usable as of itself because of market changes and stuff. So let's explore a bit. Okay. So we'll look into some of the mechanisms that have been proposed by the great people who are attending today. So Futarchy, Robin Hanson, obviously, is really interesting because if you think of having a measurable objective, so as has been introduced by Bo earlier, what is by the way, I just wrote this like vote on value, bet on beliefs, which is the way Robin had introduced it. As was mentioned, as long as we have a measurable objective, we can use prediction markets to elicit information about, for example, whether a proposal should rather pass or fail. Conditional prediction market is going to be launched for two of them for each world. So yeah, just what Bo has mentioned. So I'm just paraphrasing. And that's going to help figure out where, in which of the two worlds the information is, the objective is going to be maximized the most. And then, there's this notion of decision markets, which is basically that you just execute on what is maximized by what is picked by the prediction markets. And we can also add on top of that, so to loop back to the delegates and contributor question. So how do we produce rewards to them? So you can think of whenever a proposal is passed, some funding can be routed towards the contributor. So that if we take this information strictly from the prediction markets, that's going to be kind of proportional to the impact of the proposal if it gets passed. Yeah, so that could be a reward mechanism based on top of that. So yeah, within this realm of pure information predictions, then we can use Futarchy. Another type of mechanism, which is pretty different, but one of the interesting developments in crypto in the public goods space is a retroactive public goods funding. And more generally, retroactive funding, so which I sum up as build first, earn later. So obviously, many of you know the idea. So you contribute, get evaluated. I wrote there, for example, by trusted experts, which is not always the case. That's a question of what is the evaluation body that is going to decide on contributions, then produce a reward. So that basically the evaluation body is going to produce the rewards. And yeah, so just stopping there, we can think of this as any contribution, so notably within governance, so governance professionals producing any form of work, which is a form of project, can be funded through such a mechanism as well. Vitalik has suggested an idea which is project tokens, which is basically enabling some form of early liquidity in projects, yeah, basically just an equity mechanism on top of that can be useful also to make it easier to participate in retroactive funding projects. Yeah, so continuing to explore a bit, like what Bo has presented. So what can we use else to what kind of other situations do we have where we might want to produce rewards to contributors within governance at Uniswap, for example? So in case of Bo's, if I'm stating things right, in case of what Bo has co-authored, basically the idea is if you have, it could be that if you have several proposals in competition for resources, so notably just proposals in competition for just being passed within the DAO, so you can use this bidding plus information aggregation prediction mechanism that they propose, which is going to maximize something. So I just copied this from your blog, Bo, which is maximizing participants' welfare as well as this external social value that Bo told us about. Yeah, which enables basically the kind of outcomes under these constraints that we have this form of competition among proposals for resources. If I'm stating things right. Yeah, so under a different context, yet another mechanism basically that produces interesting outcomes. And yeah, I think I want to stop there for a second. So basically, we've seen that if we want to rely on measurable objectives, we can leverage prediction markets and thus futarchy. If we want to, yeah, in this case, if we also want to leverage information markets, but we want to use competition among proposals, we can go for this type of mechanism. If we want to have something more like, so basically not a prediction market, like that was the example before. Retroactive funding is kind of more straightforward. You just pay later. That's a good mechanism. So we were thinking about basically what can we do else than that. And so, yeah, we stumbled upon the notion of intersubjective truth, which is just a way of putting that some decisions can be made that are agreed upon by a group in a very strong way, but which are not objective. So typically, if we don't have such a thing as a measurable objective, as I mentioned in futarchy, so TVL or something like that, but that we still want to produce a form of information aggregation, we need to look into different kind of mechanisms, basically. So that's what we call an equivocal objective. So in case of Uniswap, that's maybe the more qualitative side of the objective, which has been defined, for example, during the last event in Denver, which was liquidity layer of the internet. So you can think of it as something that groups people's like intentions, let's say, maybe together around something which is clear, and you could evaluate contributions with respect to this objective. Obviously, this can be translated probably into things like TVL or like sum of TVL across different chains, and yeah, there are multiple ways definitely to build a more quantitative version of that, so we can kind of fall back to the earlier mechanisms. But in the more general sense, we are also exploring like how can we answer to this question directly. And so yeah, as I hinted at, basically that means that people need to rate or evaluate contributions, and the kind of mechanism that is going to be happening behind the scenes is a kind of proof of stake, like slash raters that are misbehaving. So you expect people to participants in this kind of mechanism to rate the contributions based on their adequacy with the liquidity layer of the internet objective, So basically, someone who is proposing something to grow TVL on a new chain will be aligned. Someone who's proposing something that is destructive to that is going to be misaligned. I mean, the contribution is going to be considered misaligned. And so there is an unequivocal way to understand like whether something is aligned or not. And we can slash if ever a rater misbehaves with this guideline. Yeah, so that's for the first part. So that kind of introducing how we arrive to this kind of mechanism, a quick overview of what has been built and we think is interesting, and that's also the reason why we're kind of bringing everyone together here. And we hope this is useful to Uniswap, obviously. If there are any questions on that, please throw them. I'm happy to take. And yeah.
What is meant by this to be? Like, does that mean I'm reading based on inaccuracy condition, or like I'm lying when I am reading? For I'm reading misbehaving means I am reading something against the factual information out there, so that, like, say a specific group gets like ahead for like what this is core I know for ascertaining.
So actually, if you think about the Ethereum validators, if they if they don't follow one of the rules, they get slashed. And so basically, every other validator is going to, and this is automatic. Every other validator is just going to have there's a if probably in the code somewhere. And they're going to update their stake to be at 0 or to be diminished, right? So this is kind of what we want to emulate. So if you have a group of raters, I will explain a bit more after. If you have a group of raters and one of them is so not following the guideline, the other raters can observe this defection and slash.
I think it's like interesting, like language based, because it's almost like if the outcome of the proposal, is bad, or like, my feature is bad relative to that, but I'm misbehaving because it's not my outcome. Like I'm not controlling, but I'm being called misbehaved. Like if I disagree with the way this information is right, is the outcome is fully it.
Yeah, so I think the point is that if I understand, this is really like slashing is only going to work in like extreme cases, and so that means it's in these cases where it's unequivocal. So you would expect that all of the participants in this mechanism, the raters, are going to clearly kind of not objectively on the human level, but not on the blockchain level. So like intersubjectively, that's the kind of the idea of that. Identify that this is a misbehaving. If there is, if there are like raters which don't have basically the same judgment, that's another problem. That's basically a limitation of this approach.
So the agent misbehaved, it's where the agent misbehaved is in the protocol is actually like really together. Think maybe how we can think about it. And like you get such strings. It's
Like, is it then we have a very clear set of rules that we can put into the code, right? And that is what we would categorize as misbehaving and then getting slashed. But it's not like we consensually come to this was misbehaving, and therefore we slash it, but more in a this is the 5 criteria that you need to follow. If you fail to follow one of these ones, this equals misbehaving.
Yeah, got it.
I think the question would be if you can determine this like up front, then maybe you don't even need the raters. So the idea is you do need the raters to interpret some rules, right? There's some interpretation, and also you want some of the boundaries to be quite large because you don't want to just remove things that are like dissenting or like you're losing some information. Sorry, Robin, you were going to say.
So you want them to slash when the rule isn't followed, although it's an ambiguous boundary, but strategically they might find other opportunities to slash in their interest, which have little to do with your boundaries being violated, right?
Yep.
Yeah,
Absolutely.
that was one of the points of the workshop yesterday.
Yeah.
To
Yeah.
observe,
Yeah, when we run the game yesterday, obviously that's one of the things that people can't determine, which is what constitutes a slashing condition. Why is somebody slashing? We were using forking actually rather than slashing. It's really ambiguous. So you have to keep reducing the things that you're producing valuations over in order to get to something that feels like fairly unequivocal. Like this is definitely something that's a violation. This is definitely something that isn't.
Yeah, I just want to quickly touch on the approach. Actually, I think what is so what we're sharing today is not a full-fledged mechanism, but it's I want to share on the approach and what we think is important basically to achieve. So we talked about rating, which is a way basically to separate wheat from chaff in contributions with respect to the objective defined by the protocol member, they say network members of the protocol. So yeah, these are the core raters, and so what we talked about is just this core, so people rating and being able to slash each other. So why is there like this slash condition? This is really the main point I want to do now, which is that it's a notion of crypto economic security. So I think our goal and what we're exploring is how to build such mechanisms in ways that are crypto economically secure, so we can use them as decision systems, basically. So the approach of slash is so basically there is proof of stake, which is kind of watch each other. That's what I was explaining. Watch each other and then slash under some conditions, which requires these very unequivocal cases. Or because if it's equivocal, then you could totally imagine that a split happens and like half of the fork is there are two forks and each have their own views or preferences, and they end up separating. Another approach is the court system approach. So basically, whenever someone believes that one of the raters has misbehaved, make an appeal to a court, which is going to decide and agree or not to slash the person. So and this requires observability. So you can have the raters observe the others and provoke these slash processes basically. And as I said, unequivocal violations with respect to the guideline, and that this doesn't fix another problem, obviously, which I'm calling here strong ratings, which is that you have a core set of raters who are going to be always basically aligned among each other. Usually, the way it's solved in blockchains is forking. It's just like you start a new chain in the older days. Today, this is like, for example, Eigen is reintroducing a bit this notion with Eigen layer with the Eigen token, but you still don't. You can't get away from the idea that you can fork your. The only way to have really aligned people together is just to fork things out. Another approach is reputation, so kind of making it harder to get a voice and thus ensuring an external form of alignment. I think I can stop here. That was just an intro to We're also thinking about scaling basically to more raters, which is there are some nice mechanisms around peer prediction that should help doing that. But that was basically an intro to the kind of mechanisms we are looking into and the approach that we hope can bring like new decision systems and secure ones, so they can be deployed, notably to Uniswap, and some protocols for their decision making and notably resource allocation.
Brilliant.
Yeah.
Any questions, anyone?
What kinds of applications are you mostly looking at? Are you right now focusing on like traditional governance questions, like in something like Uniswap, or what does that look like? Yeah, so
I think that so what we are describing here is like the resource allocation problem. So I mentioned rewards sent towards contributions. So I think we didn't touch a lot on that, but the idea is very simply that you reward the more aligned contributions, right? So you should that should create a virtuous circle where the objectives are more and more achieved through time. So that's kind of an alignment budget, if you want, as you have like security budget in blockchains. You could have like an alignment budget in a sense that makes sure that only that the incentives are there, so that the contributions that are aligned are going to happen. Those that are misaligned are not going to happen.
So I think another way of thinking about this is, imagine you had you have a protocol, you have some money being emitted every period of time, and you're allocating it in such a way that it's basically doing most of the governance job for you, because it's incentivizing people to come to the protocol, provide some labor or contribution, and that's the type of labor and contribution that does actually increase the value of the protocol. And so you start off by doing these very small protocol jobs, like we just want to pay delegate contributors, and eventually you could just keep ratcheting up to all kinds of treasury allocation problems. And that's the idea, is like it could even start funding things like kind of running like a grants thing, like a retro PGF, or it could start running investments like we saw with Arbitrum. So that's the idea, is like it should become like fairly generalizable, and it can kind of tackle lots of different problems.
I'm curious about how do you compare fast.
Mm-hmm.
I think he's taking an approach that becomes somewhat fractal and then sort of aggregating up across because you have that adjudication problem at the end. How do you really know if this was aligned or not? Right. And I think he's worried somewhat about attacks, but there's no real difference between attack and decompositions.
Yeah.
And so you're trying to assess, and then you have like the raiders read the raiders who make the skyguards. In the computational.
Yeah.
And okay, I'll send you guys.
Okay, yeah, please
Yeah.
send it. Yeah.
Because I think you'd be interested in that also.
Yeah, it'd be great to see it. Absolutely.
Yeah.
Yeah. Connor.
So yesterday when we played the game, we discovered that it's fairly hard to initiate these flags if you don't have the clear criteria. And so I'm wondering if you played it all with games or like eliciting interesting criteria or concrete criteria, and understand how that might impact the likelihood of flash bids.
Yeah, I mean, we were just saying we would have, you clearly have to provide some constraints. We provided very few constraints in the game to see how it would degrade, and it degraded. So I think that you would have to constrain it as much as possible until you get good results. But we started with something quite broad. I think you'd want to make the objective very quantifiable, which we didn't do. And then you need to add like these kind of very clear, like unequivocally, that's a bad action. For example, we could say something like, we are judging based only on how good the drawing is. So it doesn't matter, it's just, is it a good drawing? And maybe that would produce something better or worse. We could say, we just want to judge on whether it's a representation of the actual thing, the prompt. So prompts like unicorn, is it a unicorn? Yeah, that kind of looks like a unicorn, that's good. Versus the word good, lots of people have chosen different things, it's harder to interpret. So we were trying to figure out what the dimensions are of that problem. And yes, you'd have to get to things that felt like completely unequivocal. Don't know what the game is though.
Could there be a lower risk way to fork where you just say like, there's like a way to interrogate the ambiguity instead of like doing a full fork? But this is what we experienced in practice this with like people would disagree, and then after a little bit of back and forth, suddenly there'd be a line. We're like, oh yeah, it's a good one.
So actually Chainlink have a model for this, they call it watchdog, I think. And so you just have an incentive for someone to report, and you pay them if they're right. So they report and then you escalate, and it goes to like a separate group who are more trusted. So you could have like another set of raters. It just gets expensive. So it depends what you're aiming for. Robin?
So for many centuries, the usual way people in the world, when they have a group of people who want to coordinate on some rule about how they will behave with each other, they write a contract.
Yep.
So could you do a compare and contrast your approach relative to the usual approach? What are the advantages and disadvantages?
So if we were going to write a contract in this regard, you would say, hi, I'm the buyer. I want to buy this labor from the market, right? So you would have someone who says, let's enter into a contract where you will provide this service for me and I will pay for it. because that's the problem we're trying to solve, which is there's a blockchain, there's some shared resources, and the group has to coordinate on how much to allocate to which
For
contributor.
example, if I buy a painting from you, I commission an artist's work from you, I may have a specification of what counts as the artist work in a contract, and then if you provide something that meets that specification, I'm obligated to pay you for it.
Yeah.
But if it doesn't meet the specification, I can take you to court and say, you didn't give me according to the specification, so I reject your artwork, right? That's
Yeah.
how usually people do it,
Yeah.
right? So how is this approach better or worse than the usual approach?
Go on.
Is it fair to compare this to constitutions as well? Because in our case, we are looking at a host of contributions towards a protocol. So it must be a like fairly large contract. Does it make sense then to talk about constitutions or like laws? So we can check against constitution. So whether the proposed contributions are aligned or not with the constitution. So like a document.
I mean, a constitution is usually trying to bootstrap a legal system from within an organization, but most people don't have to do that. They can use an external legal system.
But I think I get your point, but I think the difference is that on one side we have someone who is procuring something for themselves, right? So, and then they're also going to provide the assessment, whether they received the value from the good, right? Whereas I think our problem is we have a pool of money or pool of resources that we share in common, and we have to figure out how to decide who to allocate this money to further some specific goal. So if you just had your protocol designer sitting in the middle of the protocol, they could do this job really well. They could just instantiate contracts with every single person, and they could assess whether they received the service. So we're trying to do the same thing, but with agents of the designer. So they're sitting there trying to say, which contract should we enter into and pay out? I think that's the difference, is that we don't have one person who can decide what's valuable. And so we need to figure out a way to collectively decide what's valuable.
But you're going to do that by collectively deciding some objective measure of what's valuable, in which case you could put that in a contract. So like a church could have a contract for the church organization, and then, hiring hookers is not part of the church contract. And if somebody uses the church budget to do that, they could challenge that in court and say, no, you have violated the terms of our church, and they would usually win that, right? So a church can specify to some degree in a contract what it is that the church is about, and therefore what's not. Right?
So I think what you're saying is something that DAOs actually do already, right? So they will have service provider contracts where they get someone to come and do something specifically for them. So contract solves this problem. But go on.
I think it's not different indeed. It's basically what I was suggesting as a way to keep in check the raters. Like this can go through a court. Yeah, that's perfectly reasonable actually. So as long as we can write to me it's a document-based approach. So I'm sorry if I'm not following the terminology, but if there is a clear objective document with this information, then you can someone can make appeal on what has been judged on by or rated on by the raters and get them slashed. So I think that this achieves the same objective.
Yeah, I think the difference is that we are trying to emulate this contract system, because the problem is that the delegates who we're specifically trying to pay sit on both sides of the contract. They're selling the labor into the DAO, and they're buying the labor as well. And so they currently do have a contract actually where they pay themselves. And so but the problem is that it's very hard to stop that system from just kind of decaying into pure bureaucracy. So that's the reason why we're trying to find a better system that makes sure that the reason they pay themselves is specifically because they are furthering the objective, not because they have power to keep paying themselves. So that was why we moved away from just like a direct contract.